Final talk, I want to talk about saltbush systems for southern Australia. But I think it's really important in this story to also look at some of the farmer case examples that are on the website, and I'd certainly encourage you to have a look at Hayley Norman's presentations on saltbush. Some really important information there. Anyway, I have some background in the saltbush area. Let me give you the story from my point of view. Things, I think, really went well in my career until we discovered the problem with saltbush, and I want to talk to you about that. Southern Australia has a fodder gap. Yeah, if you look at our weather patterns from May to one year, May the next, we've got a cool wet season and a hot dry season. We've got adequate pasture during this cool wet season, and we have deficient pasture in the dry. And there's an opportunity for us to make money from grazing saltland pastures by really using them as a feed to fill that feed gap that occurs in summer and autumn. So, as I see it, the saltland pasture opportunity is that we're going to fill that autumn feed gap using wasteland. We're going to sell the grain that we would have used to feed sheep. We'll sell that on the market. That'll increase our profits and we'll make some money. But the risk is that if we get the saltland pastures wrong, the profits are impossible, and more profoundly, our capital is wasted. So we've got to avoid that. So, rhetorical question. Can saltbush supply the nutritive requirements of sheep? When I joined the Department of Agriculture in the 1980s, I think this was the model that we had of the role of saltbush. Yep, sheep would graze that. They'd get everything that they wanted from it, and life would be good. We'd make more money. And Brian Warren and Tess Casson did a field experiment into the nutritive value of saltland pastures in the mid-1980s, which really forced us to reconsider this view. We're at the Katanning Agricultural Research Station, Gasari, and what we've got are sheep grazing a stand of saltbush without much understory. But the comparison that they make is of a dry pasture compared to saltbush. And what they do is they measure two things. They measure live weight and they measure condition score. Now, condition score is a really important thing to measure because we actually can't measure the dry weight of a living animal. We can only measure the live weight of the living animal, and the live weight can sometimes give us a really misleading impression of how the animal's travelling. Let me show you what I mean. This is, I'm going to show you two sets of numbers. After 360 sheep grazing days per hectare on saltbush or dry pasture, here are the live weight data. You can see that as a percentage of the starting conditions, the plants on the saltbush have actually been able to maintain live weight at more or less the level that they went on at, whereas the animals that have been with the dry pasture have had a live weight fall. Here are the condition data, but you can now see that in terms of condition, the animals have actually lost condition on the saltbush, but their condition is more or less okay on the dry pasture. So it's telling us something really interesting. The live weight is not telling us the true story of how these animals are travelling. And what comes out of this for me is that the superior feed value of saltbush in this situation is an illusion. And it's because of increased water intake. In the same way that a bowl of chips contains a huge amount of salt, our saltbush is containing ash concentrations in the leaves of in excess of 20%, and ash is mostly salt. And this is the relationship between the salt intake in Saltbush in terms of grams per day and water intake, you can see that the plants, the animals at least, taking in a whole lot more water associated with that increase in salt in the diet. And if you weigh an animal that's got a belly full of water, of course it'll weigh a lot more. So this explains why that weight increase is illusory. And of course, when the results of these trials came out, Warren's quoted in the media as saying that the four most common saltbush varieties have no higher sheep value than barley grass. Everything goes pear-shaped for a while. But not for too long, because we discover something really interesting about the saltland pastures when we look at it in a bit more detail with time. This is the best stand of saltbush that I ever saw. This photograph shows Clive Malcolm and Ian Walsh from the North Stirlings area frolicking in a mixed stand of saltbushes, and you can see there's a huge amount of leaf area on these plants, and these plants are transpiring, they're using groundwater, and indeed they're lowering water tables. I took a colleague back to see that site 5 years after that first photograph was taken, and this is what it looked like. Now I can assure you that those plants are still alive. They don't look very flash, do they? The leaf area has been dramatically decreased because the water tables have been drawn down. Let me show you what the water table data look like. Oh, before I do that, there's a subclover understory growing underneath these saltbushes. Those plants shouldn't be there because subclover is one of the most salt sensitive plants that we've got. So how are the subclovers growing underneath the saltbushes? Basically what's happening here is that the saltbushes are lowering the water tables and they're rehabilitating the saltland. So in 1989, when I took the first photograph, the saltbush had been recently established. We had an understory of barley grass, quite shallow water tables, 1.2 metres. 5 years later, the saltbush are pretty severely stressed. They've lost a lot of their leaves. They're still alive though. We have a substory of subclover, and the water tables have now been drawn down to 2.5 metres. That, for me, is a really important piece of information, and it's telling us something very fundamental about saltbushes. We've got a new groundwater pump here. They're leaves. They are going to be using water, lowering water tables. Let me take you to another site where we've got a much better example of this. We're at Meckering. We've got a dense saltbush plot, and we've got groundwater, shallow groundwater at this site with a salinity of about 40% seawater. That's what the plot looks like. And if you look at the daily water table log beneath this dense stand of saltbush, this is what you'll see in the summer. That diurnal movement of that diurnal rise and fall of the water table every day, the water table rising at night when the water is coming in from the outside of the plot into the middle of the plot, and then as the plants start to transpire during the day, the water table drawn down again during the day. A daily pulse. I found that really fascinating. Here's the water table drawdown due to the saltbush. What we've done here is we've subtracted the water table log beneath the saltbush from a water table log outside the saltbush area to have the specific effect, the specific drawdown due to the saltbush. That's the daily log. Here's a 24-hour average of that. You can see that we've lost a lot of the noise now. And what you get out of this, I think, is the sense that there is a 20 to 60 centimetre drawdown in the water table beneath the saltbush compared to the outlying area. I think we would have had even more drawdown if we'd had a larger plot, because I think the thing that's limited the drawdown here is that there's been lateral intrusion each night of water into this fairly small plot to keep it all topped up. Something strange has happened here. where I've drawn the arrow. What I need to tell you there is that we went in with a chainsaw and cut the plants down. There's been a rise in water table after the plants have been cut down, clearly showing that it's the plants that are having this role in creating the water table drawdown. So one solution to the problem with saltbush is probably to grow a pasture a bit like this, where we've got saltbush being primarily rows of saltbush being primarily responsible for the drawing down of the water table, and perhaps other plants like balansa clover or burr or other herbaceous species growing as an understory or perhaps an interrow, producing the bulk of the dollars.